Welcome back. In this video, we're going to explore the limit definition of a definite integral based upon sigma notation. This little Greek letter is sigma notation. These limits should be below and above, like I equals 1 up to n. But anyways, so we have this relationship right here. This is the integral from a to b of f of x dx, the definite integral we looked at in our last video. We can write this as the limit as n goes to infinity of the sum of the area of the rectangles. This represents the width of the rectangle. That represents the height of the rectangle. What we're doing is we're sending the number of rectangles to infinity, or we're sending the width, the delta x, to 0. It can't be 0, but we're sending it so it converges to 0. It's really a quite simple concept. You find delta x, which is going to be your top limit minus your bottom limit divided by n, and then find x sub I, which is just going to be your lower limit plus I times your delta x you found in the first part. And then you're going to plug that into the function f, whatever the function you have, and write it in limit notation or go back and forth. You just have to go back and forth. And what ends up happening is we send the width of those rectangles to 0. We draw infinitely many, so we have no area under the curve. Or no air of the area under the curve, I should say. So in this first one, our integral from 1 to 3, if we find delta x is going to be the 3 minus 1 divided by n, or 2 over n. The x sub I is going to be 1 plus 2 over n times I. And then f of x sub I would be 1 plus 2 over n times I, in this case squared, because the original equation is squared. If I write it using my limit definition, I'm going to take the limit as n goes to infinity of the sum of the area of the rectangles. So it's going to be I equals 1 rectangle up to n, or infinitely many rectangles. And then it's going to be the height of the rectangle, which is the 1 plus 2 over n times I squared, times the width of the rectangle, which is the 2 over n. You need to be able to go both ways on this. So that's going for my definite integral, writing it as the limit of the sum of the areas. The other way is if I give you this limit, then you need to be able to dissect it and you need to write it as a definite integral. In this particular case, this is my a value. My a value is going to be pi over 4. And then this is how far my limits are apart, because that's over n. Remember, that's b minus a over n. So in this particular case, what ends up happening is if I know that that's a, I'm going to have b minus pi over 4 over n equals pi over n. The n's will drop. So b has got to be 5 pi over 4. So now when I write my integral, those are my limits. It's going to be pi over 4, 5 pi over 4. And then my function, remember this is x sub I, so my function is my sine. So this is just sine of x dx. This is the example from the AP website, just so you know kind of their extent of it. They gave you the same idea like my first example. I'm going to find my delta x. My delta x is going to be 2 over n. And then my x sub I would be 3 plus 2i over n. And then f of x sub I would be 3 plus 2i over n. In this case would be raised to the 4th power. And so when I just kind of compare my examples, like this doesn't work, that's not going to work. This one doesn't work because of that part right there. That should be 2i over n. This part that part works, but that does not, because that's not 2 over n. This one is the right one because that's my lower limit. That's 2 over n times I raised to the 4th power times delta x, so my d value. All right, I'll clarify in class for you best I possibly can. See you soon.